What is up, guys? Name's Talon Frazier here, and today I'm going to be covering my Lab 1 over constant velocity for Physics 2111. So let's get right into it. Okay, let's start it off with a little bit of an introduction. So, the purpose of this lab was to relate the motion of an object that is moving at some constant velocity, which in this case, constant velocity meant that no net force was being applied to the object, so nothing was slowing it down, speeding it up, or making it change direction. And we were comparing that motion to a graph that was generated using a coded model via GlowScript of the exact same situation that was performed of real data collected using the tracker program. So we're basically comparing a coded model of a experiment that we ran with the marker. So the fundamental physics principles used in this lab was Newton's first law, which states that an object in motion will remain in motion unless acted upon by an outside force. In this case, there was no outside force, so that is how it was related to the constant velocity, is that there was no force being applied. And then Newton's second law, which was the momentum principle, which is shown right here in these equations. To go further, preview to basically talk about what we kind of learned from the lab. And after doing it, the computational model created was highly accurate to the calculated position, which confirms the assumptions made with constant velocity and the principle at hand. So we knew that with the constant velocity, there wouldn't be no acceleration, that it would be a very linear relationship. And using the velocity update formula, where we were able to determine that there was no acceleration, there was no force, that we were able to then take that data and graph it, and then being able to plug it into the code using the velocity update formula in order to get a computational model that lines up with the actual data that we collected. So in the actual experiment, the system thing that was being observed was the marker. The surroundings were the table of the earth slash the gravity, and then that kind of initial roll of the marker was also involved. And that's kind of what it says here in the note, is that the marker was initially at rest and then it was rolled across the table. So the steps of the experiment. To start, the recording device, which in this case was just like an iPhone, was set above a flat plane, which in this case was the table. And then a video was caught of a marker rolling across the flat surface at a constant speed. The video was then taken and it was imported into Tracker, which then allowed the position to be tracked over a time interval, and that data was able to be given to us. We then collected this data that the tracker gave us and we made a graph in Excel. After we did that, we went on to GlowScript and we coded a model of the exact same marker as it rolled at a constant speed over the same time interval. And then we were able to collect that data, go back into Excel, and make another graph. And then when we plotted that data, we compared it back to the tracker data to compare to see how accurate it was. So right quick, here is the tracker data that was used. Each of the sub intervals that we can see here was kind of just like a time interval in which the distance traveled was collected, and then that data was taken and plugged into a graph. And that graph can be seen here, but it also can be seen in the Excel version, in which the tracker data is on top, and it was compared to the GlowScript data after we coded it using the same exact difference in time and the velocity vector, and then plugged into the velocity update formula. We were able to see that the data was very, very similar, especially on slope and start and end positions over that time interval. So where could errors come into play? So in this case, we assume friction was negligible, but in reality, it isn't. So when using the GlowScript model, there could have been a slight error because the GlowScript model assumes that there is no friction, although the data that we collected using Tracker did have friction. And then anytime we're doing any kind of a lab experiment, when it has to do with recording or any type of human interaction, there could always be human error. So that could have also been an error. And then the biggest what if, the main one, is that if we would have just simply changed the axis, the slope would have changed from positive to negative. So that was a simple what if. And yeah, that's about it. Thank you for your time.